A ball is thrown upward with an initial velocity of 15 meters per second. It passes with an ES. Grammar. Passes a tree branch at a height of 7 meters. How much time goes by until it passes the branch again? Okay, so start by drawing a picture. Do I have a brown? I don't have brown. Interesting. I use red. So we have a tree. I think I got a shape for a treetop. Do I have a shape for treetop? I might. All shapes. Ooh, this one looks good. There we go. Hey, that looks actually pretty reasonable. Almost respectable. Okay, green. There we go. Whoop. So we have a tree. And there is a branch on the tree. Comes out like this. Have a ball, blue. Ball comes up like this. Comes back down. And we're saying that it passes the branch at this point here, right there. Comes up and comes back down again. And we're given an initial velocity, I'll call it V naught, of 15 meters per second. Yep, that makes sense for a velocity. And the branch right here is at 7 meters. Draw a little arrow, 7 meters. So what this question is really kind of going about is we have a parabola, forget that tail right there, and we're looking for the height at 7 meters. So this is going to be a kinematic equation. So start by writing up our equations. I guess, okay. We started by drawing the picture. Now we're writing up the equations. So we have the 3 equations. I say 3, but it's really much more like 2. So if you have a constant acceleration, the velocity will be acceleration times time plus v naught. And then distance will be x equals 1/2 at squared plus v naught t plus x naught. So from here, I'm going to use this equation right here. You can kind of see how this t squared is going to give us a quadratic, which is going to give us 2 solutions. One solution will be the first time it passes the branch. The other solution will be the second time it passes the branch. So I'm just going to start writing in what I know here. So x final will be 7 meters, because that's the height of the branch. X initial, we'll say it starts from the ground. Velocity initial, it's probably an assumption assuming it starts from the ground, but that's kind of how it's assumed. I'm going to assume 7 meters above where the ball is thrown, because that's the only thing that kind of seemed reasonable. Okay, focus. Initial velocity equals 15 meters per second, and it's in the upwards in the y direction. Meters per second. T equals question mark, and acceleration equals negative 9.8. A lot of times in the AP exam, you'll just assume that acceleration is negative 10, which makes the calculations easier. Okay. All right, so now we'll plug this in and see if we get some sort of quadratic here. So we have 1/2 times acceleration, which will be negative 4.9. So 1/2 of 9.8 is 4.9. Negative 4.9 t squared plus 15t. And then I'm going to take the x final, move it over to this side. It'll be negative 7 equals 0. Multiply everything by negative 1 so that we can, it just looks prettier. 4.9t squared minus 15t plus 7 equals 0. Do our quadratic. We'll have do I want to rearrange this? Nope, I'm good. So negative b squared plus or minus 4a, b squared minus 4ac square rooted all over quantity 2a. And then this will give us 15 plus or minus 15 squared minus 4 times a, which is 4.9, times c, which is 7. Both of those are positive, so we'll get a number that is less than 15. Then 2 times 4.9, which we know is 9.8. Okay? Yep, I'm not even going to try and do this in my head. I'm going to go straight to Wolfram. So, we'll do, wait a sec, 15, I'll do plus square root of 15 squared minus 4 times a, which was it 4.9? It's probably 4.9. Times c, which I don't remember, 7. Times 7. So b squared minus 4ac divided by, I'm going to have to quantify all of this, 2a, which is 9.8. So this should give us the bigger of the two. So it'll be 2.47. Whoop. So t equals 2.47. I know I rounded a little bit. I'm going to call this t2 because it's the big one. I know I probably should have solved for t1 first. Such is life and mistakes that I make. Whoop. Negative. And we get 0.74 equals 0.74. Okay, so then I think it asks us for the time between the two branches. How much time goes by until it passes the branch again? Okay, so we want to find, so we know this first time right here is 0.74. This second time right here is 2.47. And so we have 2.47 minus 0.74, 3, carry the 1, 4, 1.73. Whoop, 1.73 seconds. And see what our possible answers are. So the closest one we have is right there. Let's check our math real quick. So we got this is our quadratic. This is where we put it in. Wait a sec. We got this. 0.574. So this is 0.574 here. Cross this out. Click. Click. Bush League Amateur. So 2.47. I'm going to call this 57. 0, 1, 14. I could have left the 4 there and just put the 1. It's okay. So this will be about 1.90, which is probably about 1.91. Okay, so this was the correct one. Whoop. So, to recap what we did here. We had a ball that's thrown, goes over a tree branch, and then returns to that tree branch as it's falling down. And so this is basically an upside-down quadratic, which makes sense because gravity is negative 9.8 meters per second squared. Use our kinematic, first draw a picture, which is tree branch, put out our kinematic equations, and then we look at this equation right here because it gives us everything we need except for time, because we're looking for time here. And we have time in terms of a squared, which tells us we probably, or at least possibly, will get two answers. And those two answers then is what we're trying to find the difference of here. So we take those two answers, we plug things in, we don't make mathematical transcription errors, and we get an answer of about 1.9, which is about 1.91 if you're more careful with the numbers. And that is how we solve this problem. Hope it helped. I will see you on the next problem. Thanks.